This podcast is generated by AI from the most interesting articles selected by the AI Security Foundation experts. Welcome to the deep dive.
Today, we're going to take a necessary step back, away from the usual hype cycle.
Mm-hmm.
We want to examine where the AI ecosystem actually stands here in early 2026, because the breakthrough phase, that's really over. Large language models aren't just experiments anymore. They're being deployed en masse, right into critical infrastructure.
And that transition brings huge consequences. That's the defining reality right now.
It is.
If you're using these systems professionally, this shift is absolutely critical. LLMs are moving into core workflows, which means they're no longer just these abstract cloud services.
They're tangible assets now.
Exactly. They are traceable, attributable, and this is the crucial part, they're becoming targeted infrastructure. So our mission today, based on the sources, is really to define this new maturity, how we identify them, how we measure the real-world safety risks.
And what happens when attackers figure out they're just another target?
Precisely. Another server farm to go after. Okay, let's unpack this. We've synthesized our source material into, I think, 4 major shifts. First, we need to talk about the end of the black box, how researchers are learning to fingerprint individual models, even just through an API.
Right.
Second, we'll dive into the newest safety standards, specifically this PHARE benchmark, which tries to define risk. Then third, we have to look at the security reality. I mean, the sheer volume of cyber attacks we're seeing.
It's a staggering number.
It is. And finally, we'll pivot to current innovation trends, this move away from standalone models toward deep workflow integration. And we have a really interesting look at AI tackling global climate challenges. So let's start at the very beginning. Attribution. Accountability.
The fundamentals.
Right. It's fundamental for any system's integrity. If an LLM is embedded in, say, a financial system and its output causes harm or violates a regulation.
It leaks data.
Exactly. How does an organization reliably identify which model from which vendor and which version was the one responsible?
And for a long time, that was almost impossible. They felt interchangeable.
But you need that for compliance, for incident response.
That difficulty is precisely what this new research on LLMmap is designed to solve. As you said, the big hurdle is that most organizations only access these things through an API.
You're just sending a prompt and getting a response back. You have no idea what's going on inside.
You have zero visibility into the architecture, the weights, anything.
So if you can't look inside the box, how does LLMmap prove that Model A is definitively different from Model B?
It shifts the focus. It moves from architecture to what they call behavioral signatures.
Behavioral signatures.
Yeah, think about how we identify people. We don't analyze their skeletal structure, right?
Right.
We look at their unique accent or their handwriting.
Okay, I see.
LLMmap does this digitally. It constructs these very carefully designed, sometimes subtle prompts, and then it just analyzes the pattern of responses across thousands of queries.
Can you give us an example? What's a behavioral signature for an NII?
Sure. So one model might consistently show a subtle bias when it handles negation. It might be, fractionally more likely to misunderstand a not command.
Oh, interesting.
Or they might have very different refusal behaviors. You have a borderline question. One model gives you this long apologetic paragraph. Another just gives a hard one-word no.
And these quirks are consistent.
They're stable and repeatable. They're unique to that model family or even a specific version, and you can see them right through the API layer.
That is the key detail for our listener, because it means identification works without any proprietary access.
Yes, it democratizes accountability in a way. I can now analyze a proprietary model's behavior without violating any licensing agreements.
It effectively elevates LLMs from being these abstract services to, identifiable digital infrastructure components.
That's the perfect way to put it. It puts them in the same class as, say, a network device or a server that you can identify by its technical fingerprint.
But wait a minute. Doesn't identifying the model make it easier for an attacker to tailor an exploit?
Ah, yes. It's a classic double-edged capability.
So this isn't just a win for the defenders.
Not entirely. For defenders, it gives you forensic power. If you use 5 different LLM vendors, you can pinpoint which one caused a problem. But you're absolutely right. The same techniques allow an attacker to be much more precise. If I know you're running Model X version 4.1, I can deploy an attack tailored exactly to the known weaknesses, the little behavioral quirks of that specific version.
Bypassing any generic defenses you might have. That's a huge implication. So what does this LLMmap finding mean for someone setting up an AI system today?
It signals a definitive shift. We're moving beyond the idea of an interchangeable black box. The technology is forcing us to treat these models as traceable, attributable systems.
Especially as we move into what you call the agentic future.
Right, and by that we just mean systems that don't just generate text but actually do things. Book travel, manage finances. In that world, attribution becomes just as critical as authentication. You have to know which brain is running the show.
Okay, so if we can reliably identify the model, the very next question has to be, how safe is it? That brings us to our next segment. We know that the old performance benchmarks, like who scores highest on some academic test, they just don't capture harmful behavior or robustness gaps.
Not at all. And that takes us directly to PHARE. It's an acronym. It stands for Harmful and Risky Behaviors in LLMs.
Fear, okay.
And it really represents a maturation of the field. The focus shifts away from raw capability, can it solve a hard math problem, to qualitative risk exposure.
So how does FAIR actually structure that assessment? What's it looking for?
It's designed around evaluating how models respond to prompts related to misuse, to safety policies, sensitive domains like illegal activities, hate speech, that sort of thing.
So it's not asking, is the model smart? It's asking,
is the model safe to use when the stakes are high?
That must reveal some key trade-offs that developers made during safety training, right?
Absolutely. The benchmark often highlights this subtle balance between being helpful and being overly cautious.
Too much refusal.
Exactly. If a model is too safe, it might refuse to answer a legitimate but maybe sensitive medical research question. If it's too helpful, well, it might generate instructions for something harmful.
And PHARE gives you a map of where those lines are drawn for each model.
It provides structured visibility into those developer-defined safety curves.
And here's where the data becomes really actionable. Our sources confirm that the market leaders, GPT-4 class, the Claude family, Gemini class models, they consistently rank at the top for safety.
They do. They're very close. But the differences, though subtle, are what matter. They reflect those distinct safety trade-offs.
So if you're in charge of AI procurement,
this is crucial. PHARE doesn't eliminate risk, but it helps make those risks legible. It makes them manageable for sensitive deployments in finance or healthcare.
So the C-suite is no longer just looking for the smartest AI. They're looking for the one whose failure modes are the most predictable.
Precisely. The one you can mitigate.
Yeah.
PHARE shows that risk profiling is now an indispensable part of the decision. The frontier race in 2026 is rapidly shifting.
It's not just about who's fastest anymore.
No. It's fundamentally about who is most predictable under pressure. I think we should expect safety benchmarks, like PHARE, to become as influential as any performance leaderboard.
That makes perfect sense. So we've established they're traceable. We're standardizing how we measure their safety, which brings us, I guess, to the downside of all this.
The security reality check.
The reality check. AI infrastructure is now a prime target.
And this is where we have to confront that shocking data point from our sources.
The 91,000 number.
Over 91,000 distinct attack sessions were observed targeting AI deployments in production environments.
91,000 sessions. That is not a theoretical lab experiment. That is production reality. What kind of attacks are we even talking about here?
Well, the volume confirms that AI systems are now fully operational attack surfaces. Attackers are treating them exactly like any other internet-facing asset.
They're just scanning and probing them.
Just like anything else.
So are we talking about highly sophisticated, new AI-specific attacks, like advanced prompt injection?
That's the surprising part. The bulk of those 91,000 sessions focused overwhelmingly on, well, basic cyber hygiene failures.
The basics.
The basics. Exposed APIs, misconfigured services, weak authentication, poor network segmentation. It's the low-hanging fruit.
So it sounds less like a failure of the AI model and more like a failure of the team that set it up.
Absolutely. The problem isn't the LLM itself, but the scaffolding built around it. When you deploy an AI service, you're deploying a compute cluster, a data pipeline, an API endpoint.
And if that endpoint is just sitting there exposed.
Attackers don't need some clever new jailbreak. They just need a simple scanner to find a misconfigured service that they can abuse.
And what makes exploiting these systems so much higher stakes than, say, a traditional web server?
The amplified impact. It comes from the data access. AI deployments are almost always connected to highly sensitive data sources, customer records, proprietary research, internal business logic.
So exploitation isn't just about disrupting the model.
No, it means potential large-scale data exfiltration of your most valuable information. And if that LLM has decision-making authority, the impact moves from data loss to active manipulation of your core business functions.
Wow.
This just reinforces the core message here. AI security has now fully converged with traditional cybersecurity. The stakes are just much, much higher.
Okay, that completely shifts the definition of corporate security. Let's pivot now, moving from the challenges to where the innovation is actually focused in early 2026. Fellow AI's analysis suggests the landscape is defined less by these huge singular GPT moment releases
Right, the shock and awe phase is over.
and more by these continuous, incremental, but compounding improvements.
That's a crucial observation. The key focus of this new wave isn't raw intelligence. It's workflow integration and specialization. We're seeing tools designed for continuous, embedded use.
Not standalone interaction. So what does that mean in practical terms for, the average business user?
It means the AI is becoming an invisible part of the process. So instead of stopping what you're doing to go paste something into a separate chat window, the AI is already running inside your accounting software or analyzing compliance risk in real time. The competitive advantage is shifting.
So it's no longer about who has the single most powerful model for one specific task.
Correct. The advantage now belongs to whoever can integrate AI most effectively into real, messy business processes. The next wave of AI may not feel explosive, but it's going to be pervasive. It'll be running seamlessly inside every system you use.
To bring that pervasive innovation back to a high-impact, real-world application, we have a really strategic example, the new UAE initiative.
Right.
It's focused specifically on climate-resilient agriculture.
This is a tremendous use case. It connects high-performance AI directly to these urgent sustainability goals. Climate change is intensifying agricultural risks everywhere. Droughts, heat stress, water scarcity.
And traditional farming tech just can't keep up.
It can't adapt fast enough to these complex variables. So the UAE initiative is designed to accelerate that adaptation. They've launched an AI ecosystem to combat these climate-intensified risks.
What concrete steps are they taking?
They're encouraging collaborative research into machine learning for predictive modeling of crop yields, for adaptive irrigation planning under stress. They're supporting startups with infrastructure, with data.
And it's not just for their own benefit.
No, and this is crucial. They are focusing on global cooperation, aiming to share insights and tools to help regions in Africa and Asia that are being disproportionately affected.
This really demonstrates that in early 2026, the tech is mature enough to move beyond just optimizing ad clicks and start optimizing, critical planetary resources.
It absolutely does. It shows that the technology's true value often lies in its practical application to these huge global challenges.
We've covered a massive amount of ground today. We started with how models are becoming traceable with LLMmap, then the necessity of safety benchmarking with VR,
Then the sobering reality of the threat surface, those 91,000 attacks.
and finally, this crucial shift toward embedded specialization in global applications, like the climate resilience work in the UAE.
And if we connect this all back, especially to that first point about LLM fingerprinting and predictability,
Right.
the technology is clearly getting ready for wide-scale autonomy.
Right.
And this raises a really important question for you, the listener, to think about. If we know these AI systems are gaining the ability to act independently on behalf of organizations, what specific non-negotiable requirements for forensic accountability and ethical traceability should we be establishing right now to ensure trust in these future autonomous agents?
That is the right question to be asking as AI takes on more and more authority in our world. Thank you for joining us for the deep dive. We'll catch you next time.